Hello, good morning, everyone. We're just giving everyone one more second here to get connected, and then we'll begin. Great. Thank you so much, everyone, for joining us this morning for our first GoFly webinar. To get us kicked off, I'm pleased to introduce Gwen Leiter, who is the CEO and founder of GoFly. And Gwen will be getting us started this morning. Gwen?
Thank you, Paul. And hello, everyone. We are so pleased that you could join us today for our first webinar discussing the GoFly technical rules and guidelines. As you all know, our grand sponsor of the GoFly Prize is Boeing. And in addition to Boeing, we are joined by several international organizational partners, and those entities are aerospace and engineering organizations from around the world, and many of them are listed. So we are thrilled to have Boeing as our grand sponsor and to be working with our organizational partners. In addition to Boeing and these aerospace organizations and engineering organizations, GoFly is pleased to collaborate with some of the finest technical and business minds who support us as masters in the GoFly Prize. And this slide that you see here is a list of just some of the masters who are working with GoFly. We are so pleased to have them join us. In terms of the master lecture topics, on this slide, you have a sampling of a number of different master lectures that will be occurring throughout the 2-year period. So there are months where we will have one master lecture in a month, and there are months where we may have 4 or 5 different master lectures in each month. As you can see here, the lecture topics range from deep dives into particular technical concepts. And in addition to our technical masters, we also have business masters and legal masters and regulatory masters and marketing and branding masters to ensure that we are helping you as you are, for example, on the business side, fundraising, and on the legal side, ensuring that you are protecting your own intellectual property and marketing and branding, as well as the regulatory landscape, and even discussions into what happens after the GoFly Prize and how you can continue on your pathway to success. So we are very excited today to have our first webinar on the technical rules and guidelines. Just in terms of dates of importance, the GoFly Prize was launched 1 month ago, and we are very pleased to announce that we have over 1,000 innovators participating from over 70 countries across 6 continents. In terms of upcoming calendar dates that are important to note, the phase 1 submission deadline is April 18th. And as you can see here, there are other important calendar dates. All of these calendar dates and entire schedule can be found on the GoFly Prize website under the Schedule tab. So without further ado, I am introducing now our colleague Sky, who will take a deeper dive into the technical rules and guidelines. After Sky's presentation, we will have ample opportunity for Q&A, so please feel free to text us or through the chat, give us your questions. Thank you very much, and Sky, all to you.
So great, thank you for the introduction, Gwen. Like Gwen said, the topic of today's webinar is going to be on the rules. So I hesitate to call myself a master on one of those topics that were listed. The topic today is going to come from the point of view of expertise on the rules themselves. So a bit of the how and the why. The focus of the webinar today isn't going to be on the entire set of rules. GoFly is quite the journey, and we look forward to being with you on that journey. The focus today is going to be particularly on the fly-off itself. And just a little disclaimer that the only official reference will always be the rules published online at the website. So speaking of the website, we're talking about the goflyprize.com or herox.com gofly/guidelines, or the guidelines tab. And about halfway down on that tab, where it starts with fly-off tasks and measurements, from there down is, if you want to read along with today's webinar, that's the content that we're going to be focusing on. So in other words, when you show up at the fly-off, this is what you can expect. And one of the first things is the size of the device. So size is one of the very unique rules in the GoFly prize. It's one of those things that makes it a truly personal flying device. And very simply, size is measured as the largest distance between any 2 points on the device. So the verbiage from the rules, to paraphrase, is the maximum dimension in any direction. And we're talking really any direction. The maximum is 8.5 feet, or about 2.6 meters for a non-transient configuration, operator not included. And the important to note, anything that continuously moves is taken in its kind of worst case position. So anything spinning, oscillating, anything constantly moving. So there was definitely some discussion on the forum about this, and just to get some extra clarification in there on the any direction part, you can think of it as kind of like a sphere as the envelope that you can work within, but only kind of, because anything that you circumscribe a sphere around, the size measurement can actually be quite a bit less than that. So if it helps to think of a sphere, that said, you actually have a bit more freedom than that. So some may recognize the 3-point shape on the right. That's a shape of constant width. You can Google shapes of constant width, solids of constant width, and you can use that principle to maximize the amount of space you have to work with, and just make sure that any 2 points, worst case position of everything that moves, are more than that 8.5 feet limit. The other thing that we wanted to take the opportunity to clarify is this transient configuration. So there was some discussion on the forum on this topic as well, and that phrasing is in there to give you a touch more creative freedom and design freedom for launch and landing or for flight modes. But the idea is that transient configurations just aren't intended to be used in any sort of steady mode. And a colleague gave this fantastic example that really captures the intent well of a cabriolet automobile has a couple of configurations, and it has transient configurations that really aren't intended to be used in any sort of steady state and are just to get from one point to another. And that transient configuration with the convertible top going up and down does go taller than the other configurations, but it would be quite silly to see these things driving down the road frozen in one of those transient configurations or even parked. So that's a lot on size. Another one of the really unique aspects of the GoFly prize is the Sightlines requirement. And the Sightlines is about an open experience, and GoFly is about the experience of flight after all. It's basically just a cone at the eye point, and you have some freedoms to pick the orientation of this cone and the flight mode for that orientation. Basically, whatever is most favorable to you. Pick that flight mode, and then you have a bit of freedom in terms of pointing that cone to make sure that there's this open space in front of the operator. Again, just like with size, anything that has that's constantly moving or oscillating, the entire swept path of those parts are considered opaque for this requirement. And also, just because you meet this requirement, that doesn't necessarily mean that you have good visibility with your device. So in general, just keep in mind that you should also take a look at other sightlines in different modes, just to make sure the operator has a good view of whatever the operator needs in order to operate the device safely. So down in the lower right, if you want to look up that MIL standard, that's a good resource. The other thing is on transparencies. So transparencies are okay, but it's important that the transparencies not be integral to basically to the concept of the device. So essentially, you need to be able to remove the transparency and it will still work. And there was also some discussion about, well, what if I have some joints between two panels of a transparency? And in general, anything that's kind of opaque in the transparency needs to be there solely for the transparency. So after you've done a little bit of ground tech inspection, then it's time to fly, which is the fun and exciting part, of course. Based on the forum traffic, there hasn't been very much confusion about what the flight profile looks like, but I did take the opportunity to lay it out graphically here. The takeoff and landing envelope will be at the same location, but obviously just laying this out left to right. One thing just to note is on the speed course, it does have a nominal distance of 6 nautical miles, but this is defined by 2 pylons that are half a nautical mile apart, which means that in reality, doing that run is going to be quite a lot more than just cruising along straight and level for 6 nautical miles at 30 knots. So keep that in mind when you're modeling the performance of your device. And the other really important thing to note about this entire flight profile is you have quite a lot of freedom to use altitude however it suits you, and whichever is a safe altitude and advantageous altitude to operate your device. And after you fly and all the measurements are made, then you get your final score, and essentially the best score wins. There are a couple of requirements that we wanted to go over in this webinar as well. So first off, just talking about the operator, a reminder that the operator has to be at least 200 pounds or 91 kilograms. Please use that weight budget to make your operator a bit more comfortably equipped than this dummy on the right, only in his underwear. So helmets, hearing protection, gloves, things like this, please use that weight budget for something, for things that are useful for the operator. And just another reminder that we have a 5G limit in the rules, just to make sure that anybody who's running an unmanned entry doesn't take extra advantage of extra harsh operator conditions. The other one to go over was just energy and reuse, and I wanted to talk just about the intent of that is that the devices should operate on non-exotic energy sources. And a good way to think about this is just ask yourself what kinds of energy sources are available to normal everyday people, even if it's only in some parts of the world. So I know that out here in California, I can roll up to gas stations and get gaseous hydrogen. That might not be available everywhere in the world, but that's an example of something that is available to normal people somewhere. The other thing is refuelable, rechargeable requirement. You might have to prove this. You might be asked to prove that you can refuel, recharge your device, or you might really want to be able to refuel and recharge your device because you might need multiple flight attempts at the fly-off. But it's definitely in your best interest to meet the spirit of that rule. One note, though, that there is no time limit on being able to refuel or recharge. The other thing to talk about is the safety requirements. So at the top level, the safety requirements are trying to, in several words, get you to follow good aerospace practices when designing your device. So the phrasing in the rules is the device architecture at the fundamental concept level doesn't have systems or components except for primary structure, in which a single point failure results in an operator's loss of life or limb. So so whatever happens, you need to think about failures and make sure that with failures and likely failures that the operator can still make it safely to the ground. So that applies to the architecture and concept, but what about the device you have to bring to the fly-off? So the requirements is that it has to have logged flights prior to the fly-off and also prior to the flight readiness review. And you have to have thought about any gaps that the device you have at the fly-off has to something that would be kind of an aerospace grade level of reliability. And so this is enforced by the safety report. One of the best references, that's one of my favorites for doing, looking at the principles of aerospace reliability and fault tolerances, an advisory circular published by the FAA. It's AC 23-1309, and it's a good reference. And there's a flow chart in there that's quite a nice introduction to the hows and whys of making things aerospace grade reliable. That said, we're going to have a whole webinar on this topic, so look forward to that. So just to define a few terms, again, there will be a whole webinar on this topic, so we're not going to go too deep on this. A system being anywhere where two or more parts connect, and a component, just if there's a component on your device, you need to examine what happens if it fails. And if what happens when it fails is something catastrophic, then you need to go one level deeper to show that it has a very low chance of failing, or that it's a level deeper, it has some redundancy, although it doesn't always mean functional redundancy. Primary structure, it can sound like, just big parts. What it means here in this context is a single piece of material sized to expected loads with a safety factor. You can take that as infinitely reliable generally. So let's see, to use an example, if we look at a helicopter and a helicopter rotor, you might look at that and say, well, if the rotor fails, then that's a catastrophic failure. Well, the reason that helicopters are aerospace grade reliable aerospace systems is that they go a level deeper into that. And so all of these smaller components that make up the helicopter rotor meet these requirements. So every linkage is a part that is sized to expected loads with safety factors. Every nut has a retaining wire so that so that it can't fail and has some level of redundancy. So just that's just a very short introduction to aerospace grade reliability, and that's the rules. Now, before we go into the Q&A session, there were a few frequently asked questions that I wanted to go over. First off is the 20 miles requirement. Just 20 miles when we're talking about the fly-off and the prize guidelines. The flight profile that you have to do at the fly-off is a surrogate for that 20 miles. So there's no time during the prize will you be required to demonstrate maximum range or maximum endurance. And the other one that has definitely had some discussion on the forum is, does anyone anywhere mean a Part 103 ultralight? And so that's the full language for context up there. So Part 103 is great, and we think it's a great enabler for products, but it isn't part of the rules for the prize. The important thing to note, though, is it's still very important for you and for GoFly that you don't break any laws. And so that's what this language in the rules means, is that you're responsible for operating legally during your testing and practice. So know the rules and follow the rules, and don't break the law. So that's all I have. And now we'll open it up to Q&A. I think Paul has been looking at the chat and is going to moderate the Q&A.
Yeah, great. So a couple of good questions in already. Feel free to go ahead and type your questions in if you haven't already, and we'll work through some of the Q&A here. So Sky, the first question is about the 8.5 foot limit or maximum size for the flying devices. So the question is, why have that limit when something in the air has unlimited amount of space to work with being in the air, and why such a small limit when things like an increased wingspan can lead to easier flight?
So the size has really been a central tenet to the GoFly prize for since the beginning, and the important part about size is that we are trying to make a very personal flying device. And when we examined this question, we looked at both the the stored size as well as the in-flight size. And as we realized that the in-flight size that GoFly really was looking for, it was approaching really what would be appropriate to be stored. And for the sake of a simpler contest, we merged those two. Now, the 8.5-foot limit specifically is something that is intended to make the prize very challenging. And the other thing in terms of the physics of the size requirement is that if we really wanted to allow devices that were morphing in error, we don't really want to make this prize about clever morphing in order to have a small footprint just for takeoff and landing. And so part of the urban compatibility of the GoFly prize has to do with being small on the ground for storage, on the ground for takeoff and landing, but also just in the spirit of the rules and the flying experience and having the device be an extension of your body. That's why the in-flight size requirement is so small.
Great, thanks. The next question is about the visibility cone remaining free of obstacles, and a question about how that relates to things that you might want in your field of sight, like controls or cockpit gauges.
Let's see. I'll say that that's something that is a bit of a surprising question. So one way that we've validated this cone sightlines requirement is looking at other concepts that have existed that would meet this requirement. So we encourage teams to leverage basically to leverage the freedom they have in deciding the flight mode and direction of this cone in order to put those things where they need them. That said, it wouldn't surprise me if some of these devices have some tweaks in them to meet this requirement that wouldn't necessarily be in there for a product. But I'd have to go back and look at the rules for one thing. I'll do a quick check, but in general, we can move on to the next question. Let me look something up and I might come back to it.
Sounds good. The next question is about ground effect. So is there any altitude requirements, both minimum or maximum, and how does that come into a play with potentially flying within ground effect?
So the flight in ground effect is explicitly forbidden for the flight profile. So just in terms of energy requirements, you have to do the entire flight out of ground effect. There is a definition of ground effect in terms of a multiple of your size measurement for the flight profile. The other important thing to note is that the fly off site is still TBD, but we can't guarantee that it will actually be flat and level for the entire course. So you definitely want to make sure that your device is capable of at least some up and away flight, since well, one, for practical reasons, and also just it's explicitly required to be able to have the energy on board to complete the flight profile out of ground effect. And then to go back to the sight lines, I just wanted to double check. And yes, in the rules, the operator themselves is not included in these sight lines. So arms out front and things like this are not included in the sight line requirement.
Great. We got a question in about energy density in batteries and how designs now should potentially take into consideration increasing battery densities, looking out into the future for things later on. Do you have any comments sort of about batteries as they relate to the eventual fly-off?
Yeah, absolutely. So battery technology has been very slowly and steadily improving over the last, well, really over my lifetime, for a long time, if you go all the way back to lead acids. Generally, though, this contest is only 2 years away. So there, really, I wouldn't advise anybody to design something for the contest and the fly-off around battery chemistry that they don't expect to be able to place an order for a year from now. So that's, at best, is going to be small incremental changes from the current state of the art for battery technology. Now going into a little bit outside the webinar, talking about the phase 1 and phase 2 reports. If you are going to be claiming in your reports battery technology that isn't off the shelf today, then that will have to be just like any good technical proposal, that will have to be justified.
Great, thanks. Next up, there's a question about the option to have unmanned flight at the fly-off. Could you just say a little bit more about what your options are to go with manned versus unmanned, and will a dummy be provided for unmanned flight?
Yes. So what I would definitely encourage people to look at both options, the manned and the unmanned option. I think that there are going to be, for some people it will be development reasons, some people it'll be regulatory reasons to choose one or the other. But in general, at the fly-off, GoFly will provide a dummy, but this will be just a dummy. If you are providing your own dummy, then you get to use, we'll just be ballasting a dummy. But if you provide your own, you will be able to use that weight budget to put on systems that kind of are replacing some of the operator functions. So yeah, we wanted to make sure to leave it open to either option, especially since there are going to be certain control schemes, for example, that are just going to, some things are going to be easier to do manned instead of unmanned, and some things are going to be easier to do unmanned. And development-wise, the same thing is true. In some cases, it'll be easier to do it one way. Some cases, it'll be easier to do it the other way. I'm not sure if that fully answers the question, but definitely it will be advantageous for teams who are doing unmanned and kind of need and have some functions that wouldn't necessarily have to be there with a human operator on board. Putting more of those functions into your dummy weight budget will be advantageous.
Great, thanks. And another question came in about the transparency requirement. So the clarification being that some things could be not important structurally, but still important for aerodynamic performance, and just a clarification about the difference between those things.
Right. So I would say that the spirit of the transparency rule and having the transparencies not be critical for the operation of the device doesn't necessarily mean that without transparencies it still has its full performance, if that makes sense. So there definitely won't be anybody asked to remove their transparencies and do the entire flight demonstration. But hopefully every transparency, it's obvious that it could be removed and the device would still be able to fly.
Great. And then there have been a couple of questions here about weight and weight budgets and maximum weights and those sorts of things according to the weight of the eventual device. Could you talk a little bit about weight requirements?
Yeah, so the only weight requirement in all of the rules is the operator weight. So there are no other weight restrictions at all, unless you want to count the reserve. So if you're flying on fuel, then the reserve will be measured by weighing fuel before and after, and fuel consumed and fuel remaining. But no gross weight limits or of any sort.
Great, thanks. And then a question about sound and how that's going to be measured and whether all frequencies are considered equal.
So noise is a very, very complicated topic, and we recognize that the way that it's measured can have a very large effect. And we also acknowledge that the way that noise is measured for the GoFly prize isn't going to perfectly capture the psychoacoustics of every device. So that said, one of the important goals is for you, the participants, to be able to take a measurement and make predictions on your own. And for that reason, we don't want to have proprietary software or highly expensive equipment or things like this required in order for teams to kind of make their own measurements during their own testing beforehand. So the noise measurement, it is an oversimplification of the psychoacoustics and the perception of noise by people. And but that's what we're going with. So simple a weighting of the noise measurement is what we'll have. I'll take the chance to say that the particular installation of the noise measuring devices is still TBD. So we're going to do our best to release as much detail as we can as soon as we can once a fly-off site is selected, and then we'll be able to really release enough detail such that teams can as faithfully as possible replicate how noise will be measured.
Great. And I just wanted to mention as well that there's a master's lecture planned for the future that will go over noise and how it will be measured for the competition as well. So stay tuned for more information there as well. For the next question, there's a question about the statement that the device should be able to be flown by anyone. But could you just clarify a little bit? You know, it might take some training. It might take a while to learn how to fly such a device. Could you just talk a little bit about that, please?
So that kind of goes back to the slide I had on the anyone, anywhere Part 103 thing. So I'll just say that the device, the rules themselves, so the technical rules of what you have to bring to the fly-off for the contest do not mention any requirements regarding anybody who shows up as a spectator at the contest being able to fly or anything like that. So it is fully expected that anyone who comes to the fly-off will, essentially be trained and familiar with the operation of their device, and in addition to that, be able to meet the, whatever legal requirements there are to operate it, depending on the jurisdiction that they're in.
Great, thanks. So the next question is about equipment like radios or GPS and voice and data communications. Is that included in the pilot's weight requirement? So
for a manned device, it is not expected to have all, let's see. Best way to put this is that there's certain equipment that might be normally on board an airplane that is not intended to be a part of the minimum equipment for a GoFly device. So it's really just the contest and the fly-off is really about the flying experience and not about navigating in instrument conditions or anything like this. That said, for unmanned devices, there will be a requirement for a data link in most cases, and it's hard to imagine finding a fly-off range where there wouldn't be a requirement to be able to have some level of control over the device. So in terms of radio links and things like that, that would count as something that you need because it's an unmanned device that you wouldn't need if it were a human operator in the place of the dummy, and therefore you would be allowed to use those types of radio links that are for command and control as part of your dummy weight budget. So, but that said, a normal aviation VHF radio, we don't expect people to be including those, and if they did include those in the device as saying, oh, we want to have a VHF radio, then that wouldn't be going into the weight budget. Let's see. Another way to put it is simply that if it doesn't have to be there when the device is operated by a person instead of a dummy, then it can go into the dummy weight budget.
Great, thanks. So you mentioned earlier that the whole flight path might not have level and even ground underneath it. Just wanting to confirm that the takeoff and landing location will be flat and level.
Yes, so the takeoff and landing location will be flat and level. And yeah, and when we say we're going to try to have a fly off, that we're not going to try to make it hard for people, but we'll see what happens when we get a final selection of a fly off site. We just don't want people to have the expectation that things will be perfectly flat and level and completely free of, bushes and trees and things like this.
Great. Question came in about experimental fuel sources. We touched on this a little bit, but might be important to reiterate what some of the fuel requirements are.
Yeah, I'm just going to go back to that guideline of ask yourself, are there people around who have access to this type of fuel? And are they normal people who reasonably could get access? So, and we're including their aviation fuels, of course. So, but that leaves out open quite a lot. So, think about all the exotic types of vehicles used in industry and commercial and public transit and all the different fuels that they use, for example. There are a lot of different options out there. If something is being labeled experimental as a fuel source, then chances are it's not out into the world yet and isn't available commercially to anyone.
Great. There are some questions about operating temperature and what the temperature might look like at fly-off and what the designs should have to consider in terms of operating temperatures.
That's a good question, and we definitely want to make sure that we choose a fly-off site with high likelihood of having reasonably low density altitudes at the fly-off. Beyond that, that's going to just have to wait until we get to a final selection, and then we'll be able to look at kind of historical weather patterns for that location. Yeah.
There's a couple questions again about the distance at the fly-off. Can you talk a little bit about things like the distance from takeoff to the speed course and how the distance of the speed course relates to 20 miles, if at all?
So like I said, it's a surrogate that doesn't have any sort of direct relation. So the speed course is 2 pylons, half a nautical mile apart. And to do laps of the speed course, you have, it basically starts and stops. The start and stop of your speed course run is not relevant to the 2 phases of the fly-off before and after in terms of being in a hurry. So once you take off, you have time to set up transit to where the speed course will be, which we're going to try to make sure it's not very far away at all. And you'll be able to kind of be very prepared and settled when you start. And then also once you stop, you'll be able to have plenty of time to take your time to set up for the next phase, which is the touch and go. So it is definitely designed to make sure that each phase can be done in a non-rushed way, mostly for safety reasons, of course. And then the speed course itself is the pylons that you get to, the pylons kind of extend to infinity vertically. So you can use, of course, if you're able to turn very tightly and very aggressively, then that's an advantage that you have. If you're able to use altitude to your advantage and manage your energy very well during that tight course, that's also to your advantage. But we give you the freedom to work those angles.
Great. And then a couple questions have also come in about the 8.5-foot size requirement and some clarifications about what you can do with that that space. Are you allowed to put, for example, small wings or small rotors? Is there any limitations on the way you're able to use that size and space?
No, the way the question is phrased, there's no limit to what you put in there.
Great. And then is there any specification for how the device is operated or run, or any specific types of controls that are important to incorporate, or is that up to those competing?
That's completely up to those competing. And I think that there will be a mix of people who kind of put more effort into device performance and put a bit more burden on the operator and the operator skill. And some will go the other way to, especially the unmanned devices that essentially will need to be able to, have a lot of extra aids on there. But it's up to the teams.
Great. You talked a little bit about altitude density, but a question came in about the altitude for the fly off. Will it be at sea level, close to sea level? Is there any information about that?
Most, but not all, candidate fly off locations are near sea level, but can't really say anything more than that at this time.
Thanks. Just looking for some opportunities to combine a couple of questions.
Well, while you're looking through there, Paul, I'll go back to the question on the distance for the speed course run. I'll just add that because the two pylons are basically it's a two pylon course, that means that the actual distance flown is going to be, if you are flying that as an ellipse or as a circle, instead of just perfectly straight lines with perfect hairpin turns, the actual distance flown is going to be more than the nominal distance of 6 nautical miles.
Great. And then it looks like a couple of questions going back to the line of sight and the 90-degree sight cone. Is that a physical apparatus that will be used to test that? How will that be measured and verified?
So I expect that we will have a physical apparatus, and I think that some people will not want to be disassembling their devices in order to be able to get this physical apparatus located right at the eye point of the operator. So there will be there are a couple schemes that we have discussed to be able to validate this 90-degree cone, but the simplest version will be the physical thing when there aren't transparencies in the way.
Great. And just a couple of questions about eligibility. One that I'll ask for you, Gwen. Are university students allowed to participate?
Absolutely. University students can participate. The only age requirement we have is that all innovators must be over 18, or if the age of maturity in your jurisdiction is over 18, you must also comply with the age maturity range for your jurisdiction.
Great, thanks,
But
Gwen.
we absolutely welcome universities, students, and innovators and builders from all around the world.
Great, thanks. And then back to you, Sky, just a clarification about the definition of unmanned flight, just confirming that unmanned flight does include carrying the dummy with it as well, correct?
Yes, that is correct. So it definitely has to be ballasted with the dummy, and part of the pre-flight is showing that that the dummy isn't an integral structural part of the device, and that the device is, can handle a normal human person.
Great, thanks. What about things like a car type device, if it fits within the size requirement?
Can you clarify?
So that's the way the question is worded. I think it goes back again to what is types of devices are allowed.
So in general, the rules favor devices that you get on or put on rather than get in. That said, that doesn't particularly preclude any particular configuration, and the rules are crafted to be as solution agnostic as we can make them.
Great, thank you. Yeah, and I think you just addressed this a little bit, but a couple of questions have come in about getting on versus getting in. So maybe if you could just restate that one more time.
Yeah, so just in general, especially with the Sightlines requirement, devices that enclose you, like being inside of a car, where there's a lot of, in a car, there's a lot of vehicle in front of you and behind you. And if you want to see, just outside to your left, you have to really strain and, look over the windowsill. And this is why, and a car is definitely something you get in, versus, a motorcycle where you're mostly outside, the operator is mostly outside the device. That said, that is what the rules are driving toward. That doesn't necessarily mean that completely precludes anything where the operator is more enclosed. It's just that if the operator is more enclosed, then this Sightlines requirement is going to be quite a bit more difficult to meet.
Great. And then a couple of questions have come in regarding endurance. So can you just talk a little bit about the total endurance, and a question about perhaps the minimum being a 30-minute flight time worth of fuel needs to be carried. So 20 minutes for flying time and 10 minutes are reserved. Can you just talk a little bit about endurance and fuel and how those interact?
Yeah, so if you don't mind, I'll take over the screen share and just pull up the flight profile again.
Mm-hmm.
Let's see, so you see me?
Yes.
Okay, so this is the flight profile, and so the flight profile is designed such that the total endurance of the flight that you demonstrate is at least 20 minutes, which means that's from lifting off to touching down at the landing. And this endurance has to be met with all those other maneuvers. So it's quite a lot more endurance than just meeting a 20-minute endurance at your best endurance speed with the minimum amount of maneuvering. So that should hopefully answer the question, that these things all have to be demonstrated in the same flight attempt.
Great. And then just an additional Sightlines question. Is it a potential option that an operator could wear a helmet that would perhaps have like a heads-up display on it?
Yeah, and we definitely expect that most operators will be wearing helmets, and we encourage that type of safety equipment.
Great, but a heads-up display as part of that would be okay for the Sightline requirement?
Yeah.
Great. And then a question for you, Gwen, is about mentors and asking for a mentor and receiving a mentor. If you could just talk a little bit about that process.
Yes, our mentors and actually requesting a mentor for all teams, that form can be found on our website. So for any innovator or team that wants to work with a mentor, you would simply go to the website, fill out the form. We ask you to name the specific area that you would like help and a mentor. And then GoFly will match each innovator and team with a mentor within that specific area and discipline. And so in that sense, it is a matching based upon subject matter.
Great, thanks. And I think you mentioned it already, Sky, but just confirming that there's no maximum altitude for the fly off, correct?
Correct.
Great. Good. So I think that we've made it through the majority of the questions that deal with the fly off technical rules. So we're gonna wrap up here. Thank you everyone for all of your time and questions today, and we're very excited to see all of the excitement around GoFly. So thank you all for participating. We'll be putting a recording up on the GoFly site after the event. So if you'd like to listen again, you'll be able to. And if you weren't able to listen, it'll be available later for you to view there. So thank you all for your time today, and have a great day.